Hi, my name is Brett Yule, and I will be explaining the lever rule and its derivations. So, the lever rule is used when we have a substance in which there is a phase change. So, essentially what this will look like is we have temperature on the y-axis, mole fraction on the x-axis, and there's this region here, and I'm just going to label this is between A and B, which are just theoretical things, in which the top portion is liquid, the bottom portion is solid, but this middle portion is a mixture of liquid and solid. So essentially, the lever rule can help explain the composition within this range. So this is, again, two phases, which in this example are liquid and solid for some substance. Now, what we can do is we can take a theoretical point right through here, and we're just going to call this C for composition. Also, it goes along with A, B, and C. And we're going to explain how to determine the composition of C. So if we were to magnify this portion right here, it would look something like this. So here it'd be liquid up here, solid down here. Let's just say the point C is right here, and this entire region is liquid and solid. I just abbreviate it instead of writing it out. So one thing we can do is we can draw a line between these intersections right here. And this will be the point in which it all becomes solid. So we're going to, wish I drew this over more. I'm going to move the solid so I have room to write. So right here is the composition of the solid, in which for the equations to come, we will just call CS, C sub S. And right here, we have the composition of liquid. Which for the equations come, we will call Cl. So now we have essentially all of the information we can. And reason why we did this is because at these intersection points, the substance must be in a liquid or solid phase. So they're kind of like the boundaries we will use. So now it's time to perform some mass balance equations. Now, one thing to note is this C right here is equal to the total mass balance, which is going to look kind of weird. The M is for mass, B for balance, and T is just stating it's the total. Well, no, the B is for just this given part B. It's just like some portion. It doesn't stand for mass balance. It's the actual substance. So it's total mass for that divided by the normal total. So what we can do with this is we have the total for B is equal to B of the liquid plus B of the solid, which this can further be simplified to mass times composition of each of these. Now what we can then do is divide by the total mass. And one thing we will note here is the mass of of the liquid divided by total is equal to the weight fraction. So since this is for liquid, this will be the weight fraction for the liquid. So now continuing on, we can now say, because also using this, since we divide by a total mass, this left side becomes just C, and then the rest of this becomes the mole fraction of L times composition of L plus the mole fraction of S times the composition of S. And another thing to note, since these are, the W's are weight fractions, they have to add up to 1. So if we were to add WL plus WS, it would equal 1. So what we can do with this now is say WL equals 1 minus WS. And we will plug that into this equation. So we get C equals 1 minus WS times CL plus WS times CS. Which this will then equal, if we distribute the CL, CL minus CL WS plus WS CS. So now if we subtract the CL, we will then get the CL right here from C. We will get C minus CL, and we will have two things with WS. So we can go ahead and take that out and multiply it by the expression. So now if we move this parentheses part by dividing it, we will eventually get WS equals C minus CL. I'll make that L a little smaller. All divided by CS minus CL. And this is the lever rule for a solid. Now you may be wondering, oh, how do we get the weight fraction of the liquid specifically then? Well, we will use this equation right here. So since this is WS, to get WL, we just have to subtract WS from 1, which means WL will equal 1 minus C minus CL over CS minus CL. So this is the lever rule for a liquid.